Okay. The third party quality control used on Maglumi analyzers. For now, we have the Biorad and Randox quality control, but of course, you cannot find all the parameters available. So you have to make sure that the quality controls, the quality controls for the parameter you have are available in the Randox and Biorad. So let's so the quality control, they are available. I will show you that they are almost about 80 parameters that are available. These are from Biorad. You can see we have five quality controls. You can see live food check immunoassay plus control, live food check tumor marker plus control, and so on. And they are 28 parameter for the first one, 14 parameter for the second, 4 parameter for the third, 2 parameters and 5 parameters. So from Rendox we have this, from Biorad we have 5, from Rendox we have 2. So from Biorad we have 28, so 42, 46, 48, and 53. So 53 from Biorad. 53 parameters have quality controls from Biorad, plus 38 from the Randox. So 50 plus 40, 38, it is about 90 parameters that have the third-party quality control. So if you are using these parameters, you can use the third-party quality controls. If your parameter has not the third-party quality control, then you can use the only quality control from SNIPE. Okay, my friend? So if the first time you use the quality control, click on definition, control, and you add your quality control. If your quality control is displayed here, that means it is already added. Then you can, for example, modify it. For example, modify the normal range, modify the any information. But if it's the first time you use the calibration new quality control, you need to click add, and then give the name of your quality control, the lot number, the expiration date, and then click which parameter is used to, which parameter is to be controlled using this quality control. And then click add. When you click add, you enter the range. You enter the range. Of course, you target value. For the target value, you get it from the insert, similar for the range. For example, this is 10 and 20. The target value should be maybe 50. The CV, enter 15. For our calibration, we said 50%. And then the SD, you can calculate it. You can calculate it, the target SD, by using the formula. And then click save. and your QC will be here. Later, when you want to run the QC, when you click control here, it will give you when you load the samples and select control, it will give you the list and the list of control you have already added in the definition, so you can select it. If it's not added in the definition, you cannot select it from here. It will not be available when you click here. So this is why we add the information. I will send it to you, my friend. Just share your email. And if you are using the quality control from third party, you need to get the information about the quality control from their website. So if you are using the Biorad, you need to go to the www.qcnet.com and you will get the information about the range, the value for the parameter of SNIPE for Magnumi reagent. And if you are using Rendox, you are using these two quality control from Rendox, you get the information about the value from the rendox.com inserts for the reagent from SNIPE for Magnumi reagent. Okay, so everything is described in the presentation. Share your email address, I will send to you. Okay, Artem? Let's continue. So you add the quality control, then how to run the quality control after adding the quality control information in definition. How to run the quality control, firstly, without QC barcode. If you don't have the barcode labels for the QC, this is how to run it. So load the QC in the sample rack. Load the QC liquid in the sample area. Make sure no bubbles in the solution of quality control, and then follow these steps. Firstly, you need to click sample and reagent area. Click on the sample rack where your QC is loaded. Then click on the position on the sample rack. Then click quality control to indicate that it's quality control, because you don't have the barcode label. So it will not be recognized automatically as a quality control. So you need to click quality control and then select which quality control, because you have added the quality control in definition. Maybe you have two quality control for this parameter for TSH, for example. Maybe you have two different quality controls. So select which one and then click OK. And then select again TSH, your parameter, for example. Then click Start to run the calibrator to quality control. What you need to pay attention is this one, the volume of needed for the QC. When you load the QC, at least the volume should be equal. The volume should be equal to the sample volume. The QC volume should be at least equal to the sample volume plus the did volume, which is always 100 for Magnumi M series, plus an increment of about 20 microliter at least. So what means the sample volume? Means if you run the QC for TSH, for example, you need to put in the tube at least the volume of the sample volume of TSH. You know, each parameter has a sample volume required. So the sample volume for that parameter plus the did volume dead volume is all 100 microliter, plus sample volume required for that parameter, plus an increment volume to be sure our volume is enough and the pipetter will not pipette the bubbles, the air or the bubbles. Okay. I will send you later. Especially if you get the results, negative results or very low results, always think to the volume. Maybe your volume not enough. Then how to check the quality control results. For the quality controls results, you need to enter the results interface, journal, and the results, they are automatically displayed by default in the first one, in journal. You can see the sample ID, the assay parameter, the RLU, the CV, the concentration, the flag in case there is flag. And then if you want to validate your results, you can select it and click validate. When validated, the results will be no longer available in the journal. It will be stored in the QC results. And next, we will not find these results in the journal. After validation, it is always in the QC results. So if the customer call you and tell you that I cannot find my results in the journal, my QC results in journal, you need to ask him to check in the QC results, because after validation, the results will not be displayed in the journal, but in the QC results. So how to run quality controls with QC barcodes? If we are using the barcodes in the quality control tube, then it is easy to run directly without with less steps. So you need to use the labels on the tubes of the containing the quality control solution, and then load on the sample area, and then the barcode will be automatically detected and recognized by the barcode reader, and the quality control will be recognized. You don't need to click here control. And then you just click start to start the test. Then how to add multi-control information, like for example, Biorad, from Biorad, third party. You need to load your quality, you need to add the information in the same interface definition. But what is changing is that multi-control, that means your control can control not only one parameter, but multiple parameters. For example, we have seen that in here, for example, from the Biorad, you can see, for example, the LifoCheck immunoassay plus control. It is used with vitamin B12, IgM, IgG, IgE, and TSH, thyroid panel, TSH, T4, T3, FT4, FT3, and so on. So when you add your quality control, for example, I select the IFP and then I click add, and then enter all the information from the insert, from the quality insert of the quality control, the range for IFP, and then the target value for IFP, and then the target CV and SD for the IFP. After that, I add another parameter, the CEA, and then click add, and then enter the range for the CEA and the other target value. And then, for example, it is if it is, for example, used for the FSH, I also add FSH and click add, and then add the information for FSH. So one control that controls multiple parameters. Very easy. how to add multiple level controls. This is another case. Multiple level means our quality controls has more than one level. And in this situation, we need to differentiate between the levels. It is like we are adding different controls, even if it is the same control. For example, here you can see for this one, it has multiple level, 3 bottles, level 1, level 2, level 3. Okay. From Rendox, also, so for example, this one has only one level, and it is using 2 units for the results, but one level. So if you have 2 levels, then you need to differentiate between the levels by changing the last number of the lot number. So for example, you add you add here 1 for the first level, and then for when you finish, you add the second level, the same name, biorad, and then you input here 2. And then you select the parameters and the other information, and then click save, and then click add to add the third level. So you need to differentiate them. The same lot number, but modify the last parameter. Yeah, I think there is results for the comparison, but we cannot compare. In all CLIA, we cannot compare the results for samples or for QC because they are using different materials. So in the CLIA technique, different manufacturer, Abbott, Roche, Siemens, and Snipe, and so on, use different materials for the labeling and for the separation. So for the labeling, we use the magnetic microbeads and the ABI. For the others, they use the also for the substrate, we use the starter 1 in OH and H2O2 for starter 2. Other manufacturer use the ILP, use acridinium for example, for the substrate. Also, some are using the MPPD, some are using the different substrate, different labeling material. So all the manufacturers have different range. So the CLIA, one is the limitation of the CLIA technique is that we cannot unify. We cannot unify the range and the results of different manufacturers. Some of them will tell you that for the parameter 1, for the same parameter, you find that, for example, for the first manufacturer, the value is between 20 and 35, the normal value. For the second manufacturer, for the same parameter, it is maybe 15 to 40. For another parameter, for another manufacturer, it is maybe 18 to 38. It is always very different. You cannot compare, but there is comparison indicated from the ECAS and DCAS, indicating that all of them have the these results, and so on. But you cannot compare directly the results between brands, different brands. Yeah, you can get the for Maglumi, you can get if you are in touch with the salesperson, you can ask it, it will provide you this data. Yeah, we have otherwise because Snipe integrated this process of third of IQA and like DCAS or ECAS and so on. So they have, of course, they have data from the third-party quality control manufacturer. Otherwise, you will not integrate this system. You will see in the presentation I will send you, and then if you want more informations, you can get from the sales. So the value are really different from different methods. Here we are talking about methods, different. Some of them are ELISA, some of them are CLIA, some of them are RIA. But also between the same method, they are different because the manufacturer use different materials. But you can get all the reports from the IQA. They send the reports for SNIPE, of course. They have reports, they have data they can share with you. Because in order to integrate the external quality assessment, the AQA, with RECAS, DCAS, or ECAS, of course, you need to have this kind of report, this kind of study. So they can provide you. Yeah, everyone has his own range because everyone is using different material for the separation. You know, the main important step in the test, in the CLIA test, is the separation technique and the labeling technique, and all of them, they are using different technique. The separation technique, we use the magnetic microbead for SNIPE, and for the label, we use the ABI, and only SNIPE use the ABI. But for others, they use the acridiniomister, they use the ILP, and so on. So different materials are used by different manufacturers. This is why for the separation and for the labeling, and also substrate are different also. So different material means different range for the CLIA. We cannot unify all the ranges for the different manufacturer. When we compare, for example, negative results between one manufacturer and another manufacturer, we just compare if it is negative for both of them. For example, if for one manufacturer the results is the requirement for negative, the result should be less than 10. For the other one, for the second manufacturer, it should be less than 20. Then if the results is negative here, for example, if we obtain here 5, it is negative. It is okay. For the same sample, we obtain 15 for the second one, manufacturer. Here also is negative. So the results is okay between them because for both of them is negative. We don't look to the results itself. The results itself, if you consider that the results is 15, it is higher than 10 here. So it is like positive here, but it's not the same technique. You need to compare with the range from the same brand. So here it is negative, and here it is also 5. It is negative. So this is how we compare. If the normal range for one manufacturer is between 10 and 20, and for the other, it is between, for example, 15 and 30, and we get the results for example 12. 12 here is in the range, but here in the second manufacturer it is not in the range. But we cannot compare like this. This one is in the range here. We compare just with if we get here 12, it is in the range, and here we get 20 with the second method. We get 20. It is in the range. 12 is completely different from 20, but it's the good results. It's okay. Both of them are in the range in the different methods, in the different brands. Okay, they don't have the other competitors. They don't have the same technology. They don't have the same technology. Most of them are using the different markers and different. They are using the different markers. So the other competitors doesn't use the same materials for the labeling technique. They are using different substrate and different labeling material. And also for the substrate, they are using different. And for the substrate in NaOH and H2O2, they are also used by that are used by SNAP. They are also used by the other manufacturer. For example, diazorin. For example, Abbott. I think they are using trigger 1, trigger 2. That trigger 1, trigger 2 that are in NaOH and H2O2, similar to those used by SNAP. What do you mean by 7 production? What do you mean by 7 production, my friend? 7 production. Okay, the quality control is not included in the reagent kit in the vials. It is not in the integral of the reagent kit. It is another vial inside the box of reagent kit, but it's not in the 7th vial. We don't have quality controls in the integral. So this one is microbits, calibrator low, calibrator high, displacing reagent, FITC, ABI, FITC, and diluent. We don't have the So in the box containing this kit, we have a bottle of quality controls from Snipe. It can be one level or different levels. It is not included. And how the number of tests depend on the frequency of running the quality control, of course. Of course, it is enough to run the 7 tests. But the okay, because we have 7 vials, that doesn't mean so that the quality control is running 7 tests. The calibrators are not used during the quality control. For example, just use the reagent and microbeads and the quality control solution during the quality control. And when we run the tests to run the samples, the end user need to handle the samples correctly. For example, avoid shaking violently, avoid having fibrin hemolysis and blood lipids and bubbles in the sample tube because will affect the results. Also, don't freeze more than one time. The samples, the dead volume, we said the dead volume is 100 microliter. So at least we need to have 100 microliter dead volume and then add the sample volume and then another extra volume to be sure that the volume is enough. Then the centrifugation before testing. After collecting the samples, we need to centrifuge at least 15 minutes with a centrifuge with a speed of 4,000 rounds per minute. And here you need to check the insert for the parameters. Some parameters may require 10,000 rounds per minute during 10 minutes. So you need to, the end user need to check the procedures in the insert of the reagent kit. Also choose the correct tubes type according to the parameters. Then, in order to run the samples in the user software, of course, we need to load the samples physically on the analyzer in the sample area, and then enter the sample reagent area. Select this is when we are not using barcodes and when we are not using the alias. Select the sample rack, then the position on the sample rack, and then input manually the ID of the sample. This is the manual procedure. When you input manually, you need to confirm the ID. So when you write the ID, for example, you write 01, you click enter in the keyboard. It will ask you to write it again for the second time. It is to confirm. So if the second time you write it correctly as for the first time, it will be confirmed. If it is not different from the first time, it will not be accepted. This is to avoid the mistakes. And then, of course, select the parameters needed to run for this tube and then click start to start testing. So very easy. Then how to check the sample results? You need to enter in the results interface journal, similar to the quality controls results. At first, the results will be displayed in journal. But after, if you select them and validate, after you validate some results, the results will be sent to the valid results interface and will be no longer displayed in the journal interface. So if the end user cannot find the results in the journal, ask him to check in the valid results because he validated them. Then you can see the all the information displayed for the results. So we have the sample ID, the assay parameter, the RLU, the CV, the dilution if used, and the flag, the concentration and the flag. So this is the meaning of the different flag. The star means the machine error during tests. There is machine error during test. The flag E means this results has been tested by expired reagent kit. And for the C, it is calculated by expired calibration. Then the R means the results has been recalculated. The S means the suction failure during the test, aspiration issue during the testing. And the N means the needle crash during the test, needle collision. And the D means the clot detected by the needle, the sample needle during pipetting. Higher than Q or lower than Q means the QC results is outside the target range. This is for the QC only. This flag is only for QC. Lower or higher means that outside of the normal range. This is only for samples. And too much higher or too much lower means outside the assay range. This is only for the patient results, for samples. So this is the end user need to understand the meaning of the flag in order to take the required action. So for example, for the flags E and C, the results may not be accurate. Check the problem or contact engineer. For N, S, and D and star, the results shall not be validated also and need to check the problem. For higher than Q or lower than Q, check the problem and rerun the quality controls. And for the flag too high or too low, it is required to dilute the sample. So how to run the multiple sample? We can run multiple sample together by input of the first and the last, the first and the last ID, the last ID. So enter the sample and the reagent interface. Select the rack, select and then click here the first ID and the last ID, and it will be, the ID will be affected from 1 to 8, for example, for 800, from 1 to 12 for Maglumi 2000 or 4000. And the first will be 1, the second will be 2, the third will be 3, and so on. Then, of course, select the parameters and click Start to start the testing. How to run emergency samples? We load our sample, our emergency sample in the sample rack and then in the sample area, and then enter sample reagent, select the rack, select the position in the rack, and click Start. Start for the emergency samples, and then select which parameter to run for the emergency tube and click Start to start the test. Then how to run the samples requiring dilution. So firstly, you need to define some dilution ratio for each parameter. So enter definition, diluter, select the parameter, and then on the top, here on the top, you have predefined list, a list that is already existing in the software. So you can select from this list the dilution ratio you want to use for this parameter. So you can click here 1 to 10, for example, it will turn to green color. Then click here on these buttons. So here you have 9 position, 9 ratio you can select. Click here on the top, then click here on the lower side to bring this ratio to this list. If you want to use 1 to 100, click it and then click here and it will be displayed here. So you can define up to 9 dilution ratio customized for this parameter. But if you want to use a dilution ratio that is not available in the upper list, then you need to add it by yourself. Then you can click edit and then edit customized dilution ratio, the dilution ratio you want to use. Just enter the sample volume and the diluent volume and the name of the ratio, dilution ratio, and then click OK. You need to pay attention that the minimum volume for the sample should be 10 microliter, at least 10 microliter. And the total volume, sample plus diluent, should be between 200 microliter and 380 microliter. So enter definition, click diluter, select your parameter, and then you can see here on the upper side, we have a list of predefined dilution ratio. From the upper list, you can select the dilution ratio you want to use for your parameter. For example, I want to use 1 to 10. I click it on the top, then I click here, and it will be selected here, chosen. For 100, okay, it is chosen. 1 to 2, okay. Now, for example, I want to use 1 to 3. It is not available in the predefined list. It is not available. So I can add it. I can add it. So I choose a position here and I click add. And then I can define my dilution ratio, for example, 1 to 3. So I can input, for example, here 70 microliter and here 140 microliter of diluent. So 70 microliter sample, 140 microliter diluent, and this is 1 to 3. So it display you the ratio. And then I click OK. And now I have the ratio 1 to 3. So, and then you have a list of dilution ratio. Why we do this? So later for my parameter, when I want to run the dilution ratio in the sample and reagent area, when I want to dilute the parameter, this parameter, the samples using this parameter, I select the rack, I select the position in the rack, then I click dilute. When I click dilute, it will display the list of the dilution ratio I have already selected for my parameter. It will display me the dilution ratio from here. What you need to know that if your volume should be at least 10 microliter, and the total volume, for example, I want to make 1 to 4, 30, 120, sorry, 90. It is 1 to 4, but it will not be accepted because it is lower than 200. Okay, it is lower than 200 because the volume should be between 200 and 380. So of course, if I use here 100, for example, and I use here 300, it will not be accepted also because it is higher than 380. So you need to have a volume between 200 and 380 microliter. After that, how to use the dilution ratio? If I am in the sample and reagent area, select the rack, select the parameter, and then click dilute, select the position, and then click dilute. it will display then select when I click dilute, it will show me the list of dilution ratio in order to select. You can see here we have only one. If all the dilution ratio for the parameter already defined in definition will be displayed here, and then you can choose which one to be used. Another function in the user software is how to convert the sample results to QC. Sometimes maybe you have the QC, you run the QC as a sample. And if you run the QC as a sample, and then you will get the sample here, but it is normal sample, it is sample, it is normal result, sample result. You need to consider it as a quality control sample. Maybe the customer is using some some samples, patient samples as quality control. So you get after getting the results, click view, and then click view, and then click select. So select it and click validate. Sorry, click validate, and then it will be validated. And then when you click view, so firstly you need to validate. It will be displayed in the valid results, not in the journal. So firstly, go to the journal, click select it, click validate. Then it will be sent to the valid results interface. Then from the valid results interface, select it and click view. And then it will display this interface. Click convert to QC. As you know, when for the QC, we need to have the name and the lot number. This is why when we want to convert the results, the sample result to the QC, we need to enter the lot number. It is very important. Select which lot number and then click save. And then the results will be considered as a QC and it will be displayed in the QC results. Next is the system maintenance. For the system maintenance, we have in the system, we have a guidance for the end user to perform his maintenance step by step for the daily, weekly, and monthly maintenance step by step, and the help to run the automatic maintenance also. So for the daily maintenance, just need to clean the surfaces of the different component of the analyzer, and then check the consumables, empty the waste for the cuvette and the waste liquid, and then check the consumables to prepare the day after. So this daily maintenance is at the end of the day to prepare the next day. Check the consumables, including the starters. If not enough for the next day, prepare a new one, load a new one. For the system liquid, if it's not enough for the next day, prepare a new one with diluting wash liquid, wash concentrate with distilled water. Then the last one is to run prime from here. Click this button to run one prime. For the weekly maintenance, always during the weekly maintenance, clean the outer wall of all the needles, the outer side of the needles by the alcohol and the cotton swabs, including the pipetter needles and the washer needles for the injection and the aspiration. So all the needles on the analyzer. And then click on the right button to run the prime twice. For the monthly maintenance, we need to prime the chamber 10 times. Need to load the system tubing cleaning solution. You remember we said it is used during the monthly maintenance, tubing cleaning solution. 13 milliliter in the vial number 7, 6, and 5, and load it in the reagent area. And then click here to run it automatically by the analyzer. Then empty the wash liquid tank and waste liquid tank and clean them, especially the wash liquid tank. And then add the system liquid and add the system liquid and click the right button to do the prime for the washer and pipeator. So prime chamber using starters, prime pipeator and washer using wash liquid. And then the last thing is to run the system test, including the BGW and the light check, and check the results. For the BGW, the result should be between 100 and 1200 for the RLU, and the CV less than 10. For the light check, the result the RLU should be less than between 450,000 and 650,000, and the CV less than 3. If your results are meeting this requirement, then your system test is successful. Then at the end of the day, before you log out the software and you switch off the analyzer, make sure there is no test ongoing. And then seal the reagent kit, remove them from the reagent area, and use this sealing film to seal the vials of the reagent kit, and then store it in the refrigerator. Then press the button, this button, to quit, and then click OK to quit the user software. Then turn off the submain switch. So this time you start by the submain switch, and then after that, after 3 seconds, the main switch. Then check the consumable status. If not enough, prepare a new one. That's all for this second presentation. Thank you for listening. Do you have any other questions? So if you don't have other questions, or if you have other questions also, you can ask. Yeah, we don't have the biotin interference like in Roche. We don't have the biotin interference because we don't have this biotin interference, and we don't have interference with for temperature, pH, and so on, because we don't, our labeling is not enzyme, and for the biotin, it's only Roche that they have this because it is included in the material they are using. The others, all the others, they don't have the interference for biotin. Only Roche have this. Yeah. For Roche, before using the sample, before collecting the sample from the patient from Roche, for Roche, if the patient has the biotin intake, the biotin under some treatment using the biotin, they need to wait at least 8 hours, about 8 hours after the starting by the time when the patient intake the biotin, wait 8 times in order to collect the sample from this patient. Because otherwise, because there is interference with the biotin. We don't have with SNIPE. I think Siemens and the others don't have also this. So we take a 10 minutes break and then we continue. Okay, later we will see the user software. Most of the things we have seen in the SOP, so we will see the user software quickly, and then we'll show you the consumable calculator, just about 10 minutes for the consumable calculator, and we will see the user software, and the training will be finished. So see you.
Recording stopped.